Hello, I hope you're having a wonderful day, and I hope that you're also ready to learn as much as you could ever want to know about geological folds. Alright, let's get to it. So, in order to learn everything we're going to need to know about folds, we must first ask ourselves, what is a geological fold? And at its simplest description, a geological fold is a formation of several layers of rock that, when put under compression, have bent instead of broken to form a new structure of deformed and compacted minerals. Here's several examples that you can see of different types of folds that are made of different minerals and have different types of formations. The folds that exist today that we see have most likely been formed millions of years ago, but they haven't always been around. When they formed, they were rock layers deep beneath the Earth's crust that experienced high compression and temperature over a very long period of time, like millions of years kind of time. And then if the pressure and temperature stayed at the right level and the rock layer had enough plasticity, then the layering would actually bend instead of break, and it would form into a new structure of deformation and layering that is called a fold. These folds then become exposed to the Earth's surface through erosion and uplift of different sediments that are above it on the Earth's layers. Here's a few examples of folds that have been brought to the surface through this form of uplift or eroding of other minerals around it. As you might know, there's quite a different amount of folds, but not only different in shape, but also in size. The smallest types of folds are called dime-sized folds, and they can be very small, like fit in the palm of your hand, or even so small that the naked eye can't even see them. They are normally formed from metamorphic rock. The next types of folds are the ones that you'd expect to see, and probably the most stereotypical of the folds, and those are the outcrop folds. And they are normally on hillsides or on cliff sides or under ledges, and they are good medium-sized fold that really just is standard, honestly. And then the fold that I didn't expect, and I don't think anyone else expected to be a fold, but if you look at it, it technically is, would be the mountain-sized folds, and those are folds that actually make up the mountain ranges of the world, and they can extend for hundreds of and thousands of kilometers, and they are just ginormous folds that form the mountains that we see today. So here you can see what a typical fold would look like with the correct labeling and measurements. In the middle you can see, imagine it like this. This is the fold. The middle is the axial plane, and that is what separates the two halves of the fold, and it goes right down the middle as about as symmetrically as it can. And then at the top, at the very peak point of the bends in the fold, at the either top or the bottom, depends on which way it's going, up or down, is the fold point or the hinge line. There's a few names for it. And that is basically just the point of measurement that is where most curvature happens. Like, it is the sharpest point on the fold. And then extending from there are the two limbs, and they just extend from the hinge line or the fold point down or up to the next fold. Scientists and geologists in the field use these types of measurements to classify and compare different types of folds. Now I'll go ahead and talk about all the different types of classifications and descriptors that scientists and geologists use to classify said folds. First is the anticline, and that is the part of the fold that is arching upward where all the rock strata is arching towards the sky, and that is most easily identifiable as the part of the fold where the rock layer that is the oldest is at the very core of the fold, and the rock that is youngest is at the fold point. And then you'd have your syncline, which is the other way around, where it forms a U-type formation, and that is when the youngest layer of rock is at the core of the fold and the oldest is at the bottom. And you can have trouble remembering these because there's not really many good ways to remember them. So what I do is I remember that the arch one, anticline, forms an A. Anticline, A. And then the syncline, it sinks down like a U sinks, and so that's how I remember both of those. These two are very important things to remember when talking about folds. Another descriptor that we can use when classifying folds is the positioning and orientation of the axial plane compared to the angle and symmetry of the limbs extending from it. Here we can see a fold where the axial plane is vertical and the limbs coming off of it are pretty symmetrical and have a pretty similar angle and distance from the axial plane. And as long as they're roughly similar or the same, that's considered a symmetric fold, which honestly is not very common in society, in nature, but it is seen sometimes, as like in the photo. And more commonly is an asymmetric fold, which shows the axial plane does not evenly bisect the fold itself, and the angles of the limbs coming off are quite different. And that is more common in the world around us, and these types of descriptors are good for telling us how the fold was formed and at what speed it was formed. Another way that we can classify and determine different qualities of different kinds of folds is by the orientation and angle of the fold hinge. Again, the fold hinge is the point on the fold that is at the top of the anticline and the bottom of the syncline, where the curvature is most sharp going down to both sides. But for this, we're mostly going to be talking about anticline for this example, since it is talking about the surface of the world and what we can see. And so basically, the fold hinge on a non-plunging or horizontal fold, which is the top example here, is when the fold hinge is flat and level all the way across, and this is more commonly seen in the world around us and in nature. However, sometimes the fold will fall and part of it will dip down and change the angle of the fold entirely, and that'll cause a plunging hinge, which is rare, and when it occurs it leaves a zigzag type pattern in the earth around it. A few other ways that you can classify folds are by whether or not they have a fold hinge, and then whether or not the fold goes up or down. And a few folds that don't have a fold hinge would be the domes and the basins. A dome, as you can see, for example, is a type of formation where the rock gets pushed up and the strata all form upward like an anticline. However, there's no fold hinge, and quite similarly to an anticline, the oldest rock in this would be right in the center or the core, and the outside layer would be the youngest. You can see this at certain places like Half Dome Mountain, Half Dome Peak, and other just rock outcroppings that are bulbous in nature. On the other end of the spectrum, you can see a basin, which is a formation that goes down into the earth like a hole or a bowl, and the youngest layer of rock would be what you see, which is the core of the fold. In this situation, the strata is pushing outward away from the axial plane. Here you can see two better graphics of a dome and a basin, and they're labeled with the important features of both. Lastly, we'll just look at a rare instance where metamorphism actually takes part in the folding process. In this situation, as you can see in the photo in front of you, the layers of rock and mineral have actually become parallel to the axial plane and formed what is known as a process called foliation. And when foliation occurs, the folding of the rock layers can actually bend at any angle relative to the axial plane. It doesn't matter what angle. And that should just about cover everything you'll need to know about geological folds. And if you study this hard and review the slides that you just seen, then you should have no problem remembering it. Thank you.